Today, we are diving into one of the most powerful yet, let's be honest, widely misunderstood tools in modern IT. Consider this explainer your ultimate day one guide to completely demystifying the CMDB. We are going to strip away all that heavy jargon, look right at the underlying structure, and make the architectural magic behind it feel incredibly intuitive. Let's assume it's 2 p.m. on a Tuesday, red lights are flashing all over the monitoring dashboards, your customer support lines are blowing up, and executives are pacing the floor asking this exact high stakes question: why is the login service down? In a massive, complex enterprise environment, how do you even begin to find the needle in that digital haystack? Do you just guess? Do you start rebooting random servers? Obviously not. You consult your single source of operational truth, you consult your CMDB. Okay, let's dive into this masterclass syllabus. We'll look at what exists beyond the spreadsheet, break down the foundational concepts, tackle the myth that an asset DB equals a CMDB, explore some killer use cases, and finally give you your day one challenge beyond the spreadsheet. Forget those flat, static rows and columns of traditional IT management. A configuration management database or CMDB is a repository storing info about IT system components, which we call CIs. But, and this is absolutely crucial, focus on the second half of that definition. It stores how those components relate to each other without the relationships. You literally just have a static inventory list. Now, what's really interesting here is this ultimate aha moment. A CMDB isn't just a list, it's a graph. It's a dynamic living network. If you ever seen a complex mind map or a social network diagram, that's exactly what we are building. The components are the nodes and the relationships are the edges connecting them. That graph structure is the secret sauce that gives the CMDB its operational horsepower. Section 2, the 4 foundational concepts. We are going to build your understanding of this architecture entirely from the ground up. Think of these 4 concepts as a logical stack where each piece layers perfectly on top of the last. First up, configuration items, second CI classes, third attributes, and fourth relationships. So let's unpack concept 1, configuration items or CIs. A CI is basically anything you need to manage to deliver an IT service. It's the stuff in your environment. These are the nodes in our graph. Now, obviously, this includes a hardware like a server or a network switch and software like an app or a database. But check out the end of that list. A business service, a contract, a person. Absolutely. If you need to track IT to run IT ops effectively, it is a prime candidate to be a CI. The scope is surprisingly broad. Let's move to concept 2 and see how this builds. You can just have millions of CIs sitting in a giant chaotic pile. They need taxonomy. CI classes dictate this hierarchy. Notice how hardware drills down from a general CI to hardware, then to a server, and finally down to a physical server. Software goes from CI to software to application down to a web application. This hierarchy is super important because the class dictates what specific details we track for what item and what relationship rules it has to follow. And those specific details bring us to concept 3, attributes. These are the unique properties that flesh out a CI. If your CI is a physical server, its attributes might be the hostname, the IP address, OS version, CPU count, who owns it, whether it's prod or dev, and its physical location. Think of attributes kind of like a character sheet in a role-playing game. They give life and specific stats to the item, and naturally these change depend on the CI class. A contract CI isn't going to have an IP address, but it will absolutely have an expiration date. Finally, concept 4, relationships. These are the edges in a graph, and honestly, this is where the magic really happens. Relationships define how our CIs interact, and this brilliantly illustrates how the whole ecosystem breathes. You might have a web app that runs on a specific server, that server connects to a load balancer, and that entire service might be managed by a specific person. By mapping these out, we don't just have a bucket of parts, we have a fully mapped, interconnected digital universe. Asset DB CMDB. Now, people often assume an asset database and a CMDB are exactly the same thing. No way. Let's walk through this metrics to clear up this massive misconception. The primary question an asset DB asks is what? What do we own? It is completely focused on financial tracking, procurement, and depreciation. It usually has 0 relationships mapped out, and it's heavily used by finance and procurement teams. A CMDB, on the other hand, asks how does it all work together? Its focus is strictly operational and on service delivery. The relationships are its core feature and it's the daily driver for IT ops, change management, and incident management teams. So the crucial point is this fundamental paradigm shift. An asset DB case that you bought a $10,000 server last year and its warranty expires next month. A CMDB, it doesn't really care what it costs. It cares that this specific server is currently powering the payroll application. And if it loses power, no one gets paid on Friday. It's the difference between owning a list and managing a living ecosystem. 3 killer use cases. Alright, this is where the rubber meets the road. Use case number 1 starts with a terrifying but real scenario. An expected hardware failure. A primary server in your data center just died. The immediate operational panic is always, if this server goes down, what services break? Enter impact analysis. In a flat spreadsheet, you just know a server is broken, cool. But in a CMDB, because you have those relationships modeled, you can instantly see the domino effect. You jump into the graph, find the server node, and trace the edges upward. Okay, this server hosts database A. Database A feeds application B. Application B is a primary customer checkout portal. Instantly, you know the business impact of a technical failure. No guessing required. Use case number 2 is preventive. Say a network engineer submits a ticket to upgrade the firmware on a core router at 2 a.m. on a Sunday. Sounds totally safe, right? But the critical question is what will be affected by this change? This is change management. Blind IT modifications are a massive cause of self-inflicted outages. With a CMDB, your team can literally traverse the relationship graph starting from what router. You can visualize the entire blast radius before anyone even thinks about hitting the deploy button. You might discover that yeah, it's 2 a.m. locally, but that router connects to a server cluster heavily used by an overseas office right in the middle of their workday. Disaster averted, all thanks to the graph. And for our third killer use case, let's bring it full circle back to the hook question where we started with. Why is the login service down? You aren't preventing an issue here. You're actively fighting a fire. This is incident management. When the login service node on your graph flashes red, you don't guess. You use the CMDB to follow the relationship edges upstream. Let's see. The login service relies on the authentication app. App looks healthy. The app relies on a security database. Healthy. The database runs on a specific storage volume. Boom. The storage volume is showing 100% full. By following the connections, you just isolated the exact root cause CI in minutes instead of hours. It is literally a game changer. Your day one challenge. You've covered some incredible ground today in this explainer, from flat lists to dynamic graphs, busting myths, and fighting with digital fires. Now I want to challenge you to turn this passive learning into active application. Look at your own current work environment or an environment you are targeting and mentally list out 10 configuration items right now. Remember, it can be hardware, software, services, or even people. Once you have those 10 CIs, your challenge is to identify at least 3 distinct relationship types between them before we tackle day 2. Does CI number 1 run on CI number 4? Does CI number 7 manage CI number 2? I promise you, completing this quick mental exercise will completely rewire how you view IT infrastructure, and it's going to make the advanced CI design we tackle. Next time, click instantly. So what does your graph look like? Dive in, map it out, and I'll catch you in the next explain.